Well, hello friends. Welcome back to browser hacking. Today we're going to do kind of a challenge of sorts because I was talking to my old friend Oliver here from we used to work on the Safari team together back in the day, and he was asking me about the demos on his website. When are these going to run in the Serenity OS browser? And we were talking about the Raytracer one specifically. So this was something Oliver made, I don't know, like at least 10 years ago, probably even longer ago. And it's a JavaScript and Canvas ray tracer. And I figured, why don't we try to bring this to life in the Serenity browser? And it's going to take all kinds of stuff, but if we just sit down and work on it, maybe we can make it happen. Let's see. So first thing is that this is an HTTPS only website that Oliver runs, so we're going to have to make a local copy, but I think that will be okay. So we'll make a copy here, we'll call it Ray.js. And I think there are, a bunch of sub-resources here, so we'll just grab these. And this one. All right, sorry for DOSing you and your website with these multi-kilobyte gets. Come on now. So I guess we can look at it quickly to see what it does. So it's a web page that has a bunch of scripts loaded from external source, which we should be okay with since we implemented script source yesterday, actually. And then we have a canvas here, and there's some stuff inside the canvas which we're probably going to render because we don't ignore stuff inside canvases, but maybe that's okay. Well, we have a big canvas and then some scripts here. So we have creating new DOM nodes and manipulating the DOM. We don't support that. We're going to have to fix that. And then we have some use of dates, array construction, custom object here that he's defined somewhere or declared somewhere, and a little bit of arithmetic, array expressions. Then we got some canvas context action, a little bit of navigator object, which we also have actually, although we don't have index of on strings. So, oh, well, geez, it's still downloading. How is that so slow? I'm just gonna try that again. What are you doing? All right, so here we go. Let's just double verify that we can run this in a local Firefox. Okay. So let's just bring this up in the Serenity browser just to see sort of where we're at, get our bearings, see what fails first. So can we just open it like, oh, not like that. Well, that URL is not even correct. Anon. Why doesn't that work? That's weird. Okay, I don't know why that was happening. So we have some problems here. The parser is upset. Oh, that's probably because of the inline JavaScript. Okay, so let's ignore that problem with the file URL loading, and instead we're just going to hack browsers so that it starts up by going to this test page directly. Okay, real sophisticated. And then the parsing issues, I bet you that it's because of the script tag parsing. So we have, so we have less than characters which the HTML parser will interpret as start of new tags. So I've been ignoring this problem for a while, but I guess we gotta deal with it. Let's see. So yeah, actually we can see what this looks like, because if we dump the DOM, it's gonna look hilarious. We'll have a script tag with some text and then some really bizarre looking tags inside of it. So yeah, now we get straight here, dump DOM tree, and we can see here that this this tag here, which is some sort of very confusing outcome from the HTML parser interpreting a less than character as a start of a new tag. So, well, how are we going to deal with that? I guess, so when we, in the parser, when we open a new tag, from that point we're just accumulating text until we encounter one of these guys. So I'm thinking that we're just gonna have to, do we have peak here? I didn't look at this for so long. Yes, so I'm thinking if we're inside of a script tag, we can just peek ahead and see if this is the close script tag coming up. If not, we'll just accumulate this character and keep accumulating text. So if in script tag, this is very hackish. Should really go and implement a proper HTML spec parser at some point, but definitely not right now. So if we're in the script tag, and then if peak one is let's see, do we have two lower? Yes, we do. Okay, so we'll do this. Okay. Getting really very, very sophisticated here. All right. So if we find this, we will treat it as the real thing. All right. And let's see, wait, do this pool. Is script close time? Oh, I guess actually we didn't need that one, so we could write it out like, no, that's awkward. Ugh. Okay, if is script close tag. If it's not that, then just break. What happens when we break? We go all the way down here. Wait, how does this work? Oh, it's a loop, we just go around, okay. So we actually don't want to break. We want to continue down here so that we accumulate the text. So if we're in a script tag, I guess we can make a new one. So, okay, let me just put something like this. In script tag is false for now. State is missing a bunch of things apparently because I have neglected to close something. Wait, no. What have I even done here? What have we done? wait. No, there are too many. Okay, we're having some very silly problems right now. So this stuff right here is not supposed to end here. Okay, so if is script close tag treat as text. True. Oh man, this is such a hack. All right. Okay. How will we live with ourselves? And how is this still totally wrong? What have I done? That's that. That's, oh, the switch ends here. Oh, that's so stupid. Okay, now everything's back to normal. Anyway, yeah, so we'll peek ahead and look if there's a script close tag coming, otherwise we'll treat it as text. So let's see if that solves our immediate DOM problem. And make apps browser. Okay, so still lots of parser error messages. Let's do a DOM dump. Not looking very hot. All right, so maybe we should take a peek at what the script actually looks like. So we're looking for this guy right here. So oh right, we never set in script tag. Forgot about that one. So in script tag, we're going to track that. I guess, actually, we don't need to track that. We can just look at the node stack and see if the last node is a HTML script element. So we can maybe hack it like this for now. Check if the tag name is script. Okay. All right, well, that went better, it seems, because we got this thing right here. So let's see how the DOM looks like now. And look at that, we have our full script here, and it includes less than characters. So one problem solved. Let's just commit that right away, even though it's a bit hideous. Live web. Ignore treat characters as part of the text inside script. We encounter a during parsing, HTML parsing. We now look ahead to see if there is a full script coming, otherwise we treat it as text. This makes it possible to use in inline scripts. All right. So what was our next problem? We had a bunch of parse failures, right? So I guess we should look at those. So what were the problems really? We had unexpected token 4 when we expected a curly open. So maybe we can find that easily by just eyeballing the thing. So do we have a bunch of for loops here? Oh, maybe they're in one of the external scripts actually. So let's see, grep for loops in each one. That's okay. So let's use the magic of the JS tool to just see if we can get an error by just throwing them into the parser like this. Okay, so this one has some parse problems. Do. I think we haven't implemented do at all, so we'll have to deal with that. Renderer can parse. Okay, RT structs, that's where the for thing is coming from. So let's take a quick gander here, see what this might be. It might be this guy right here, actually, if we are always expecting for loops to have curlies. The JS parser. Parse for statement. We always expect a block statement, which we expect to have curly open. But I think for loops don't have to have block statements, right? I'm gonna go peek at the Babel spec like we always do. For statement, the body is just a statement, so probably we should just parse a statement. Let's try that. Parse statement. And for statement takes a scope node as the body. Well, we could really take a statement if we wanted to, I think. Or actually we probably have to take a scope node. But then what does parse statement return? Returns a statement. So will this even compile, I wonder? Okay, it does. It compiles because... Wait, why does that work? Statement is an AST node, which inherits from nothing but ref counted. Okay? And oh wait, hold on. For statement, parse statement, but I think scope node is a statement. Yes, okay, so that's why it works. So we can probably leave this. I'm a little bit suspicious of it, but maybe it's okay. So let's see what we can do here. I already built, so I don't know what I'm trying to achieve. Let's see if the parser accepts that for loop now that it doesn't have curlies. Which one was it? RT struct? I feel like the for loop went in. This guy still has trouble with do, of course. And then we have percent tokens, which we're not expecting. So for this fix, we could make a test, actually. So let's be good boys and do that. Let's see, for basic, for no curlies. So we'll make a for loop. I0, I3 plus plus I4, varj. And then we will, what are we going to do here? We'll make some number go up. Number plus plus. Okay. This is so ugly, by the way. I really dislike this style of programming because it's so hard to see how the loops really work. Like, if you just do this, for me, this helps so much to see what scopes really are. Anyway, so then we can just assert that the number is 9. Okay. And for no curlies. It passes in V8. Let's see if it passes our rigorous testing. Run test. Look at that, 4 no curlies. Test passed. Man, this test suite keeps growing. It's so cool. Okay, so let's add this and that. Allow for statement without curly braces around body. Cool. And then let's see, what was the other problem? It was complaining about percent. So what's the percent in, wait, was it this file? I guess so. So we got percent, so it's modulo. And there's 4 of them. I feel like there was 4 error messages. So let's see, parse. See how those look like here. So 1 modulo 3. So it's a binary expression with the modulo operator. And let's do that. Binary expression. We don't have modulo, so I guess we can just add that. Percent. This is so weird. Plus, minus, asterisk, slash. Like, maybe the names should be more like what they actually do, like modulo. These names weird me out. Anyway, let's see. So now we have the modulo up there, and then when we execute this guy, we're going to have to add a new guy here. So case binary op modulo mod left hand side, right hand side. Okay, that's very good. And let's also add some dumping for that. So binary expression dump exactly. We'll just say binary op modulo upstring is percent. Great. And then we'll need to go in JS value and add a function that knows how to modulo these guys. So modulo. Okay, where's div? Let's put him next to div. It's going to be a carbon copy of div, actually. We'll just do this. There's probably some nuance to this, but I'm just going to skip right over it and go straight for that. Invalid operands to binary expression. Double and double. Oh, is modulo always a binary expression? Did not realize that. So does that mean that it always makes int conversion, or does it mean that we to I32? We can do that. Modulo doubles. Wait, what? I am so weirded out right now. Hold on. I never messed with any of this. Yeah, see, it actually does something, which is what I would have expected it to. So let's skip over this problem for now. Fix me. We should It seems like JavaScript should allow modulo for doubles as well. But we're not going to deal with that at this hot moment, so we'll just and I'm just super hoping that it's not going to matter here, but it might. I don't know. We'll see. We'll find out if this is causing us trouble. So what else do we have here? I just want to make a new test. So for no curlies, modulo basic JS. So what do we test? 10 modulo 3 is 1? I don't know. Okay, pass this in V8, which would be very strange if it didn't. And oh, that's a big recompile because we changed the JS value header. Apps browser. I'm sure that somebody watching knows about this, but I never encountered this issue before, so I didn't even realize it was a thing. Alright, so JS tests, and we'll just run the modulo basic. That's concerning. So we passed the test, but we also can't parse it because we forgot to add parsing for modulo. So %. Well, we do crap out the token, but we don't parse it. So where do we have the binary expression? It's a secondary expression. So match secondary needs to know about %. Is it here? %. It's not there. Okay, so match sec. We'll just add it next to the slash. %. Okay, and then not there, here. After we encounter him in the context of a secondary expression, then %. We will create a fateful AST node with the binary op modulo. Okay, there we go. JS and sync and run. And look at it go. It worked. Fantastic. Okay. So we'll add that and this and that and this and that and that and JS. Basic support for the modulo. Binary expressions. Okay. And then what was happening next? So, right, we just want to parse everything. So let's just see where we can parse that whole file now. So parsing is step 1 of making everything work. Our t-structs, look at us parsing it. Very nice. Renderer, parse, flawless. this guy. We need do. So what is going on here? There's a do, and then we also had commas. Oh, it's declaring multiple variables with commas. Oh, I haven't seen that before. Wonder how that parses. 1b2. It's a variable declaration with multiple declarators. Interesting. All right, well, I guess we have to learn to parse that. And also the do statement. So let's add the do statement first. Let's look up what it's supposed to contain. Do statement. Oh, it's a do while statement. Okay. Do while statement. Inherits from while statement. Oh, okay. So this is the do statement, and this is the while statement, but there's inheritance. Makes sense. Or wait, no, hold on. There's not inheritance. I'm lying to you. It's just called do while statement. Fair enough. So maybe we'll put this guy. I feel like we can put him based on the for statement. So do while statement. Oh wait, maybe we actually have while statement already. Yes, we do. So let's copy that instead. Don't have to be all silly. While statement has a predicate and predicate. Here it's called a test. I think the correct name is actually test, not predicate. We should fix that. Let's fix that first. Call it test and test. Test and body. That's good. I like to try to keep things sort of aligned with the terminology used by the JavaScript spec and other implementations of parsers, because it just makes it a lot easier to compare and to read the spec if you're using the same terminology instead of inventing your own. So it's a small change, but we'll take it. Oops. Lit.js. Rename while statement. Predicate to body. This name matches other parsers. Okay, and then let's copy paste this fella. So now we have a do while statement as well. Oh, dang it, I forgot to change the name of this thing here. Add, commit, amend. Okay, now we can do it. The do while statement, which presumably looks very similar or exactly the same as the while statement, just that the test is evaluated at another point. So we'll see how the while statement is implemented here. And I think we'll just make a carbon copy. Do while. And then we can actually write it out like this. That's a little bit funny. Yeah, that'll work. So, okay, that's pretty good. And then we also need to dump it. So where is the while statement? Dump. We will say do while. then it's just a commas remaining. So let's see how that goes. Is it B tree? Nope, we still forgot about the do. Dang it. Okay, so it's a new expression. So we have do here, so it's gonna match it. Match a do statement. Parse statement, but then parse statement doesn't know about do, he only knows about while. Where's while? Wait, we don't parse while statements? Oh shit, we don't. Okay, well. I guess the while statements predate the parsers. That was when we were still only doing the AST manually. So, token type, we'll do the do first then, since that's what we're working on. Parse do while statement. We'll do that. Non-null ref putter do while statement. Parse do while. Okay, and then it's a matter of consuming a token called token type do. And does it require curlies? Can you do like do I++ while? Or can, wait. Why is this such trouble? 2 + 2. You can actually do this. Okay, that's really weird. So then this body is just a statement? Okay, fine, that's okay. So do, and then body is parse statement. And then we have a test. So consume a token type while, followed by an expression. So test is parse expression with no metadata about that. And then is that the whole thing? I guess so. Then we can just return a new AST node. Forgot the construction stuff. Test and body. Okay, and then let's make some tests for it since we want to be good boys. So for no curlies, do while basic JS. While, let's see, var I, no, hold on. While number less than 9. Okay, we're kind of making extremely simple tests for now, but maybe it's okay. Do number ++ while number less than 3. Assert number 3. Alright. Oh, right, semicolon. So that works, and let's make sure that we can run it too. All right, still got it. Very nice. Oh, and we should have actually checked how much we can parse of that thing now. So JS battery. Now just the commas remaining. We're getting closer. JS libjs add support for two file statements. Yep, basically that. I guess I'll leave a while statement parsing for some other time, since we don't need it right this very moment. Okay, so now we only have these guys left. So what the heck is a variable declaration here then? Variable declaration has a like a collection of declarators. Declarators. Declarators? Declarators? Let's call it declarator. Let's call it declarator. Yeah. So we don't have the concept of a declarator at all right now. So I guess we'll need to add that. Variable declaration should probably also inherit from declaration, actually. Right now it inherits from statement. Declarator? Declaration. Okay, where are these things? I'm just trying to find it. Declaration is a statement. Well, so it might be nice to just insert a little thing in between here, just for the correctness sake. Doesn't have to be fancier than that. And then we'll say that this is a declaration. Function declaration will also be a declaration. And maybe this needs to be further up then, actually. Where's function declaration? Here. Okay, so we'll put that here. Just making sure that it's still built, and I think we'll be happy with that. So we'll just commit that right away. libjs add declaration class to the AST. This is just to make the AST class hierarchy more spec-like. Okay. That's good. And then variable declaration. We need to have the declarators, right? So variable declarator. What is a declarator? It's an AST node. And what does one of these fellas contain? An ID and an optional initialization expression. Cool. So this is, we'll use an identifier for now, so we don't support patterns. So we'll require an identifier. Ref per expression init init. All right. Okay, so that's good. And then we'll need the class name. And we'll also need to be able to execute these guys. So we'll just add execute and dump functions here, and we should be good. Well, let's add accessors. So this one will be a const amp, whereas the init guy will be a const star. So since it's a ref putter, not a non-null ref putter. Okay, cool beans. And then variable declaration has to change a bit, because now he will have, wait, variable declaration. Yeah, so this guy has a kind, the declaration. So I was thinking, like, could you do var? I was thinking, could you do var I is 0, let b is x, but it doesn't work. So it's var or nothing. That's good. So we get rid of the identifier and initializer here. And we don't want this guy or that guy. Get rid of that. And instead we will have a non-null ref putter vector to variable declarators called declarations. See, that's a strange name. I would have expected that to be declarators. But what do I know? Declarations. Okay, fine. Declarations. Okay, and then when we execute one of these dudes, we probably need to iterate over all of our declarations then. Declarations. And then if declarator has an init, bust out on exception, that's good. And the name is once again here in the declarator. Declarator. It. Yeah. Because, yeah, that's good. String. This does not execute anything, so it's just looking at the identifier expression. The way identifiers work is a little bit busted in the interpreter right now, so it's something we should look at later, but not today. Okay, so I think that's good. Basically that means that the declarators, they don't have to do anything, so we can just, because nobody executes them, so we'll just say assert not reached, and like note, this node is handled by variable declaration. Okay, and then for dump, let's see how we dump this. Oh, it's right here. I can put these guys below. Variable declarator dump. Okay, and then we'll do something like this, I guess. Print indent. Or let's just do this, AST node dump. That's good. And can get rid of this, and then we'll just say declarator in mDeclarations, declarator dump intent +1. Yes. Okay, and now we have to learn to parse once again. So JS parser, parse variable declaration. Yeah, okay, so let's actually look at what it was doing in the code, these commas. So it's var, I guess it's var every time, yeah, okay. Parse variable declaration. So first we find a declaration type, and then here we're gonna have to make a loop or something. So if match token type identifier, oopsie doopsie. Guess we should say while we have an identifier coming up next. And then we'll make a vector here of the variable declarators, which is what we will pass down here to the AST node creation. So declarations and name. We'll just update these names here. Init. Okay, and then declarations append create ast node variable declarator with id and init. Good. And then if match token type comma consume. So we'll eat a comma and then see if we have another one. Does that make sense? I don't love it. What if we do this? If we have a comma, then we'll do something like this. If we find a comma, then we will consume it and continue once again, otherwise we'll break. I guess that'll work. Could also do this, but it's a bit easier to reason about it. Or I find it easier to understand if it does that. Alright, so let's test that out. What did we mess up here? Ast h44 on 605. We can't construct one of these guys because we're passing a non-null ref per vector of declarators. Yeah, it's so hard to say. I feel like the kind of declaration comes first logically, so we'll do that. Okay. And who was creating that guy? We'll put that first. Oopsie. You don't like me on line 666. Declarator takes an id and an expression. And what's wrong with that? Oh, because id is a string. Okay, so I'll have to make an identifier. just to be good boys. Good. JS battery. All right, it goes through the parser. Let's see what it looks like. We have those variable declarations. So we have var d. I'd like to see one that has multiple. Variable declaration, var. What's one that we should look for? I guess we can make our own actually. Var, comma, with var multiple declarators. Here we'll just do something like B2, C3. And C is A plus B. Can we do that? That worked. I wonder if we can handle it. Look at that. Oh, and actually, let's take a look at the AST as well. Variable declaration. Kind is var. And look at that, multiple declarators. Beautiful. That's really nice. Okay, so the JS support variable declaration with multiple declarators, which adds support and the parser and interpreter for things like A1, B2, C is A plus B. Variable declaration is now a collection, a sequence. Variable declarators. You know what? I'm going to go back and add one of those guys. Much better. Okay, so that's nice. That means that we are actually parsed. Let's maybe we can go in and open up the test page, see what it takes us this time. Oh, oh shit, we forgot to rebuild the browser. We've only been relinking the JavaScript test program. Alright, look at that, not a single parser problem. Does that mean that we can click here and things will actually happen? Oh, we don't support JavaScript links. Interesting. Okay, so I guess that will be the next thing. I'm just gonna get some more tea. Okay, thanks to the magic of video editing, we're back. So let's see. So we need a JavaScript URL support. Right. How the heck do those things work again? I guess we just take whatever comes after the colon in the thing and then evaluate that as JavaScript, right? JavaScript URL MDN. This is I feel like this browser engine and everything is in large part implemented based on the MDN spec. So I always go to MDN, but I gotta say MDN is a freaking awesome resource for web stuff. I really like it. Mozilla people who make this are very good, I think, at making this website. It's just absolutely stellar job. So this is not what I was looking for, though. JavaScript : can we search for that? JavaScript ahref here. So I was praising MDN there, but it's not their fault that I couldn't find it. It's just I don't know what this thing is actually called. I always just thought of it as like a JavaScript URL. This is shorthand for... Wow, that doesn't seem exactly accurate, but okay. So we'll just we will just run the script that comes after the colon and see how it goes. I think that'll be okay. So HTML anchor element. So click handling is in the HTML view, and mouse down on HTML view. So we're hitting a layout node with the click, and we found an enclosing link element around the node, and then we say on link click. So I think here currently we always delegate to the whoever is instantiating the HTML view, but I think in the case of a JavaScript URL we can actually handle that internally internally inside HTML view. So maybe we'll do something like if link href starts with JavaScript : then we can go somewhere else. Otherwise, we will send it out. Then we might change my mind about this later, how this should work, but because maybe you would want to be able to audit links before following them, but right now we're just going to do it this way. So say run JavaScript URL link href. Okay, and we will HTML view run JavaScript URL. I guess it's, or wait, what do we actually get? href is a string. Okay, so it's a string. And we can assert that the URL starts with JavaScript. And let's just, this might be an interesting public API, but we should have a better public API for this sort of thing. So we'll do it this way for now. So script source is URL substring view starting after 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So after 11 characters, and we could have a better API for this, I feel like, but currently we don't have one, so this is not super expressive that you have to repeat yourself. I don't love that. So anyway, we will grab some libjs stuff here, or maybe we don't actually. We can just tell the document to run the script. If we don't have a document, then we can't run it. But if we do, we can put the assertion. Flailing around too much. Okay. So we'll say document run JavaScript source. Execute script. JavaScript. Yeah, that's okay. Run JavaScript. Maybe we should even give you the JS value that comes out of it. Const string view. Okay. JS value document run JavaScript. Wait, where do we actually parse? The script element. Okay, so we'll do this. We need to import the parser here. Yeah, maybe this is good enough. If program return empty. Oh wait, this always succeeds? Okay, yeah. We're gonna have to fix this at some point, that the parser needs to be able to fail in some more logical way. Currently it fails very, like, ooh, here are some replacement AST nodes that represent failure, but it's a bit hazy how to handle that situation. We need a better story for that. But anyway, don't have to do everything at once. So back to HTML view. We wanted to run the JavaScript, but then we needed the JS value to be understood. So that's okay. We can just do that. And we're ignoring the return value here anyway, so whatever. But we shouldn't ignore returning something, so we'll do that. So that's pretty cool if that works. And we should running JS from URL. Let me just make sure that I got the substringing done right here. Just closing some tabs and closing some terminals. Oh, maybe I shouldn't have closed that one. This one we can close. This one I didn't even remember. So let's see what it says now when we try to run this. Clickety. Okay, running JS from URL render. And then nothing happens, but we don't know what to make of that. So let's see, I guess we can try to dump it actually. Debug document run JavaScript will run. libjs and libweb and browser and sync and run. Oh. Clickety. So maybe that did not parse. But why wouldn't that parse though? Render. If we have something that only looks like that. it parses correctly. So why would this fail? Let's see. I'm skeptical. I mean, obviously, if we can't parse that string... Oh, no. Okay, the AST is coming out here. I'm stupid. Okay. So maybe we're actually calling render then. Let's see, Ray.js, render. Okay, we can't do that. Render, where are you? Are you in renderer.js? Like, oh, fgrep can't do that? Jeez Louise. Okay. Render. Okay, these tools are not strong enough to search code yet. Noted. Render. Oh, it's in the HTML file itself. That's silly. So, all right, so here we are. So maybe we'll just put something in here to test that we're actually running. Hi. If we get the hi, that means that we are doing something right. Okay. All right, we got the hi, but then nothing else. So let's see. I guess we have no way of knowing that something's going wrong. I think one thing that we should do is we should probably log whenever we throw an exception in the engine, because right now we don't, and it's making it kind of hard to see what's going on. So let's log something here. Throwing exception value. Yeah. I think because we're probably throwing some exception and we just don't see it. It's very invisible. We could do the old Internet Explorer thing and throw up a message box about it. Okay, we have an exception. That's great. It's a little bit uninteresting, but we know it's an error, so we could actually even dump a backtrace when this happens, actually, because then we'll see what is throwing it. Poof. All right, so who are you? We are running, look at this beautiful backtrace. Mouse down event, run JavaScript URL, run JavaScript, go into the script, call the function. Now we're in the function and we're declaring variables. And we're about to do a call expression. So we're declaring some variables. Presumably maybe the very first one. Maybe this thing right here fails. It'll be kind of, we can just bring up the REPL and test out some basic stuff. So new date, that works. Var s is new date, get time. That actually worked. That's really cool. So, but this is probably not going to work because we don't have a Ray constructor, do we? We don't have a Ray constructor. Well, we need better error messages, actually. Let's see. If let's see, if exception is error, exception value is error. Wait, how do we know if it's an error? Is error, oh, right, we have to check first. If it's an object and exception value as object is error, then so we can log that. All right, hold on. Because we have a little bit more error message info here. We just need to actually extract it. I think, oh shit, we don't have, no, we do have error. So what's it called then? Dot name, and the error dot message. I think those are the two things we have. I would like to see a very descriptive error for like, dude, there's no such thing as array, sorry. That's actually pretty helpful. So let's see. I just looked at my phone because it was Twitter notifying me about Oliver doing something. So it's a bit funny because I'm working on his test or his demo. But I didn't tell him I was going to do it, so hopefully he will be happily surprised. So that's a really good error message. Do we see the same if we do this in the browser? So if we click here, clickety-click. Yes, throwing JS exception reference error array not known. Super helpful. This we can actually debug. Okay, so I guess we should commit that JavaScript URL execution thing. So we'll do that first. I'll leave that one alone for now. libweb. Handle JavaScript URLs. Libweb. This patch makes it possible to execute JavaScript by clicking on a link element with href, or should we say an anchor element with href JavaScript. Your script here. It's pretty cool. Maybe we should put that one up here this time. Alright, so moving forward, what else did we have? Maybe we should commit this, but I mean it's debug output, so I think we're gonna have this. Let's just say git commit throwing JS error, let's say. Throwing JavaScript error. Yes. Right. Log. Log when we throw a JavaScript error. This makes debugging a lot easier since we actually learned that something that error got thrown. All right. You know, we can be a little friendly and capitalize the E here just to indicate that it refers to a proper error object. All right, so that's great. Now, let me get rid of some gunk here, actually. All right, that's a bit better. So, oh wait, did I really want this? Yeah, I'll leave that in. think. Or, yeah, let's leave it in. So let's see. Now we want the array constructor. So libjs runtime. So which constructors do we have? Date, error, function, and object. So I guess this one is a bit like object. So we're just going to add the bare minimum that we need, I think. See, tippity tippity. Array constructor. And what does he do with these guys? Array, is there any like array dot? No, it's just new array. Okay. Array constructor. Oh, wait, back up. That's the one that we wanted. So, array length. So if it's 2 or more arguments, then the arguments are elements. If it's 1 argument, then it's the length of the new array. So the way we handle arrays in libjs right now is a little quirky because we sort of treat them separately from regular objects, but really there needs to be a little bit of merging there because regular objects can also have like numeric index properties. So that needs some work, but we don't have to get into everything right now. But we're not going to add any of these things. This will be a very simple constructor object. So we need array constructor and our prototype. Wait, the prototype of the array constructor is the object prototype, right? Array. No, not that prototype, the prototype property. Wait, how do I know what that is? Array prototype. 8 constructor. Needs to be the array prototype. Yeah. Okay, that makes more sense. And then we don't add any new functions to this guy, but instead we just make the constructor. That's all we're going to do today. Construct, call, and call. Make a new array. But we need to handle the argument. So depending on the argument count, the behavior is a bit different. If interpreter argument count is 1, and we allocate an array, and then we gotta resize that array. So elements resize to argument 0 to I32. Right, and then return array. If we have more, then we'll put a fix me about that. Fix me handle array new array user e1. Yeah. So we'll just assert now reached here, and then we can come in and fix that up some other time. I like to like stick to implementing the thing that I'm trying to achieve right now, and then leave these guys around, because if you go down every little hole and try to do everything, then it's really hard to make macro progress. You're only making micro progress, and micro progress is demotivating over time, for me at least. So, did we forget to add array constructor to the make file? No, we didn't. Oh shit, wait a minute. I'm editing object constructor CPP here. Okay, well that was a bit of a mix-up. So these guys need to swap places. I was editing the wrong file. Okay, and we are back to normal, hopefully. So that's cool. Then let's go to the global object and add the array constructor. And this is really nice. Well, we can make a test for this too, actually. Do we have some constructor thing here? ls graph con. I guess we can just say, wait, what do we do new? So these are so many tests. Damn, these are like Linus has been making a ton of patches for libjs, and it's really awesome stuff. And he makes these long tests, and he's so good about it. And I'm not taking nearly the same amount of time that he does making these tests. So super shout outs to Linus for his awesome tests. All right, what are we messing up here? Undefined. That's a pass. All right. So new array 1, 2, 3. Oh no, say 5. X length is 5. Okay, can we run this program? Oof, that did not work out well. So what are we failing on here? Failing on a call to something. So we can, we're doing it to object. Is it this guy right here? Okay. Yeah, debuggability still has a long way to go, but we can always do something like that. You know what, let's just use the REPL. Okay. That failed. Oh, because I'm not passing any arguments. Oh, heck. What's supposed to happen then? The only argument. So it's only a single argument. So if you pass multiple arguments, it should be an empty array. Or 0 arguments, it should be an empty array. So if int let's just say if interpreter argument count is 0, then return heap allocate array. Could also do it that way. Okay. New array 5. New array. Okay. No? Still no? What was wrong with it then? Type of array. Object. Type of new array. These things are not working out right. So why do they work for the function constructor? Oh, because it's a good boy and it's doing this. So our length should it be 1? I'm unsure what this should be here. It says 1 here, so fine, let's do 1 then. But array prototype had the wrong length. Function prototype has length 0. So what's the array prototype length in V8? 0. Okay, so let's just steal that. Array prototype. Zoom, zoom, zoom. Oh, look at that, array.js passed up here. These tests would run a lot faster if we didn't do a full, extremely noisy garbage collection after each one. And most of the time spent is just printing everything in the garbage collector. So this is good. This means that we can graduate to the next step. So we'll just add all of this gunk. Commit libjs add array constructor. Basic array constructor is we only support array with 0 or 1 parameters so far. Okay, that's fine. So then let's go and see what breaks next in the little demo. Clickety. Okay, type error. Undefined is not a function. Well, that's cool. So, not the most helpful, since we don't know where it's failing, but at least it's telling us something. Undefined is not a function. Let's go and put that backtrace back just for now. At least we can look at the AST in the backtrace, and we can get some clue of where we are. Maybe we could even make it the AST able to dump itself and highlight the node, a specific node. Or it could even highlight the call stack. Like, hey, this thing is on the call stack. We'll see. Okay, I feel like this did not Oh, we didn't rebuild the browser. Shit. Or not shit, but oops. Okay. Come on now, darling. So we are running JavaScript URL. This is presumably the render call. And we have some call. So this will be very hard to debug if we can't see what's going on. So I guess we could dump the call stack. So for auto frame and m call stack. So we'll just do something like this. I frame dot. Oh, we only know the argument. Oh man, we don't know anything about anything here. That's a bit annoying. Push call. Well, we can do better. We can actually add some information about who is pushing. Push call frame. So let's see. Interpreter call. We can add an optional argument here that's like AST node caller. I'll put her. And then when who's actually calling this call expression does call. No, he pushes the call frame himself and then calls function call the function. All right, okay, back up. So let's get rid of that weird thing. And in call expression, when we push the call frame, then we can just set AST node this. I think this will be interesting because then, let's see. So AST node, null footer. Yeah, const. Because then we can, when we walk the call stack, we can see what's on there. Okay, that'll be something, and then what we could even do here is we could oh no, let's be nice about it. Let's not like spam with the whole AST, but if we have an AST node, then we can log the type of AST node. Let's do that like this. AST is frame AST node last name. Something like that, maybe. And we gotta increment the thingy. It'd be good if we could actually see the AST though. So when we throw, we can also dump the. How do we find the AST? We don't, so we'll have to dump it when we run the script. JavaScript URL. Maybe we'll need to dump the whole AST actually to make this somewhat reasonable. We'll see. This is by far the biggest thing I've tried to debug here. Because normally we're like making little test programs, right? And much easier to understand what's going on. So what's on our stack? We have a call expression, a new expression, call, and a call. All right, well, that's not the most helpful information, but it is something. So call expression execute. So we could probably do an AST dump on these guys, and it wouldn't be so bad because it's actually pretty small. So if frame AST node, then frame AST node dump. We'll do a dump with an indent of 4. We'll see what that looks like. Click. I was expecting more things to happen. Oh, right, yeah, because the dump is coming in the terminal window, not on the debugger. So I need to get used to that. Okay, so what do we have here? We are... this is a bit hard to follow since they're interleaved. If we can fix that by doing printf here as well. It's a bit weird, but I think that'll be the easiest solution for now. So, like that. Wait, this isn't even what I meant to do. Oh, but it's okay to do that as well. But we needed to printf down here. NPS. All right. I++, frame ast node, and ast characters. And then we just need stdio. And this is some pretty bare bones debugging facilities, but we're gonna make it work. All right, come here, you clown. So this is our call stack from the bottom up. So we're calling render from a call expression, and then we're making a new triangle with these arguments. Then inside triangle, we're calling normalize, and then inside normalize, I guess we are calling length vector. And I guess this is what goes wrong. So let's go look at length vector. Where's triangle? It's in RT structs. So triangle getting 3 arguments, that's great. And then it's calling normalize with an S because Oliver is from New Zealand land. So bug fix. All right, so presumably it's this call here to normalize because that's the only one in here. So normalize. That calls length vector of v. Okay. Self. Does that mean something in JavaScript that I'm not aware of? Probably it does. It's a de facto name. It's not a keyword, it's a property of window. Really? Self. Does it mean something in here? No. So it's just an argument name. Does it mean something in the browser context? Okay, so it refers to the window object. That's okay, but here it's just this guy. Okay. So I would guess that SQRT is the problem. That would make perfect sense, because SQRT is math SQRT. I wonder why he did it that way. Because we don't have square root. So that's actually pretty debuggable, or pretty fixable rather. So we'll just put native function SQRT. Okay, and this will be a function on the math object, squirt, and we'll put it here, R as squirty. Let's look this up, or let's play with it here. Squirt. That's nan, so that's good. And then math squirt 9 is 3, 9 comma 2, also 3. All right, so what if we squirt nan? We get nan. Then, oh, this should just be math.m actually. Okay, and value squirt. Wait, what does it say here? Squirt. Yeah, we want to do is regular squirt. So colon squirt on interpreter argument 0. Oh no, we have it already. It's number as double. Okay. And let's be good boys and make a test. So let's see, math. We have math abs, so we'll do math squirt. Math squirt 9 equal to 3. Me and my extremely advanced tests. So that works. Actually, we should rebuild. Oh, heck. Right, this one has to be like this now. Gotta say that these are in the global namespace. Sometimes I wonder why C++ doesn't just do overload resolution here, since interpreter amp can't possibly be overloaded with an integer, but whatever. That's not how it works. So we'll do that. Oh, we got a crash. At least that's something new. And let's run the test. Math squirt pass. Great. So we have a new patch. Libraries, libjs. So this thing we should leave alone. We should only do the math object. libjs, add math squirt. Okay, cool. Now we can go back in and see what was failing next. All right, so hit me with that crash again. Let's see what that was about. So this time it's not throwing a JavaScript exception, we're actually asserting. So what are we asserting? We're asserting toObject on a member expression. So it's an assert not reached, probably. And member expression execute. ToObject. Why are we failing ToObject? Assert not reached. So we can't handle whatever the thing is. So it's a value is not object, not string, not null, not undefined. Let's log what the value is. Dying because I can't toObject on this. So let's just log the value and see what it is. It's probably some primitive that we need to synthesize a number object or something for. We'll see. Clickety. I can't toObject on 0. So we just need to make a number object. That's easy enough, right? So let's see. JS. And we'll go in runtime. So we sort of have string object. That's our only primitive wrapper object so far, so we'll copy that one. And with the H file as well. Okay, runtime number object. You know, this might take a while to finish this, but let's just keep going. See how far we can get. So number object is going to be a number object. And inside of every number object is a very proud double. I guess. That's how it works, right? Yeah, like you put a double in here. We'll just put a double in here for now. Value of is going to be mValue. This guy, wait, this guy can be private. Is string object definitely not true? Is number object definitely true? But we might not need that. So we don't need that. This guy can be like that. My cat is whining at me outside the door. Chilla, not now. Maybe later. So let's see. Number object. What do we want to do with this guy? I guess for now we'll just construct him. Number object. And we'll need a number prototype, I guess. Yes, okay. We don't actually need to have a visit children because this guy does not have any meaningful garbage collector interactions other than his prototype, but that's already taken care of by the object class. So we don't need to override visit children. But we do need a number prototype. So what is in the number prototype? So how do we find that out? Number 0. And then we get prototype of n. Okay, all right. And what's actually in here? Then p dot. Oh, you can actually tab things. That's so nice that you can tab here in the V8 REPL. So what do we care about? I guess none of these things really matter. All that we care about is having something. So string prototype, we'll just take this as a template. Because like later on we can add to exponential, to fixed, and so on, but right now we don't have to care about that, I think. Too many terminals again. So we'll take string prototype. Almost. String. Okay. Number proto. Oh. We're getting there. So get rid of these guys. Boom. What is the number prototype length? It's not a thing. All right, well, we don't have to care about that. Number prototype. Clickety, clackety. For now, this is very simple, actually. Yeah, it's dead simple, since we don't need to add anything. Okay. And then we just need to make sure that we create one of these guys on a startup. And that we protect it. And then we allow you to fetch it from the interpreter. Okay. So I think that's good. Maybe not quite. Number prototype was not forgot to include it. Oops. Cool, cool. Click. Ooh, look at that crash. So we still can't do object on 0, right, because we never actually called the number object thingy to object. So if is number, return heap allocate a number object and value as double. Having some trouble clicking the link there. Asserting that the property is an identifier. So we have some array expression where the member expression is not an identifier. So that's a bit troublesome. Let's see. If it's not an identifier, then what are you then? Dump asked. Or no, not dump asked. We'll just say debug, no, printf, not an identifier as expected. Property dump. Let's find out what this thing is. So we're trying to do an object dot something, and the something is not an identifier, which is a bit suspicious because I think we shouldn't construct this situation for ourselves. Not an identifier as expected. Wait a minute. That's not the case. I forgot to if m property is identifier. It's not an identifier. Actually, I could probably just have looked at the last one, but let's just do that again. So, not an identifier as expected, and we have a numeric literal. So we have a member expression that's not computed. So not computed means that it's object dot something, and we're computing this part. But if it's a computed member expression, it's object bracket something bracket. So this is computed, this is not computed. So in the not computed case, we're doing object dot 7. Is that legit? Can you do that? O.7 is as 1. No, that's not okay. So how did we end up in this situation? Let's dump ourselves. So dump. I'm curious, what the heck is this member expression even look like? We have a member expression computed is false. Not an identifier. 0.7. Oh shit. No way. We're interpreting these guys as member expressions. But they are numbers. Because I guess we think that this, the Lexer is getting this wrong, I guess. So, number, where do we make numbers here? Number, numeric literal. Do we have any like fix me's about fix me? Numeric literal. Well, it is a numeric literal. I guess the problem right here is that we're not parsing this right. All right, so in the parser, what do? We make a numeric literal consume double value. Need to parse double instead of int. Yeah, that's true. And we should also allow dots. We should allow one dot inside numeric literals. So let's go for a quick fix here, I think. So we'll allow a one dot. Dot count is 0. Okay, and then we'll say dot count 0. Consume is consumes one character. Wait, hold on. We'll do this very, very simple. Current char is either a dot or yeah. We'll tolerate multiple dots because I don't want to mess with this too much right now. And then we'll need to be better at parsing them. So Do we have some kind of fractional parse? We don't really. Do we do that anywhere? Strt. We have strtol in the standard library. We could use that. So yeah, let's just use that. Wait, that's strtol. That's not strtod. Oh dang, do we have strtod? We do have strtod. Yeah. All right, so we can use strtod. So double strtod for m value characters. Oh, wait, this is not completely safe. Fix me handle. I mean, actually, if we already parsed the token, then we can just parse it like that here. If we already accepted it as a numeric literal, we don't have to validate strtod, even though it can fail right now, but we're just skipping over that part. So JS 0.1, that super fails because we can't do object. And is that because I did rebuild everything? It's still a member expression, so let's bring up the ast. Yeah, it's a member expression, 0 point. It's so silly. So I guess I didn't do the lexing part well enough. Is digit. Wait, why doesn't that work? I'm confused. While the current character is either dot or mCurrentChar. And what does consume do? It depends. It doesn't depend anything. Next. Okay, now it's working. All right, I did something wrong. That's great. So let's try that. And now all we got is backtrace. That's a bit weird. I guess, oh wait, in the interpreter we added a backtrace here. So we might have nothing on the call stack. Oh, but is it just because of this? Run JavaScript. Where's this backtrace coming from? Oh wait, I can just see it right here. It's right here. That's such a silly question. Where's the backtrace coming from? How about you look at the top of the backtrace? Okay, so we are doing this correctly. Value to object. Wait. I'm still confused. I thought I was solving everything, but there is no dump backtrace here. Right? So to object. We're not seeing this dying thing. The app is still running. What's happening? Are we throwing, but not something that we can understand? Oh, it's throwing it. I have to look here. I keep forgetting. Okay, type error. ToObject on null or undefined. And then this is our entire call stack. Okay. So why are we doing a ToObject on it? I guess that's what we can use this backtrace for. So we are in an assignment expression. Wait, this is run JavaScript. So this is the call to render. This is render, run render, and then we have an expression statement with an assignment, and then there's a null value in there. So can we track this down inside the render function, which is a little bit chunky, but maybe there are some tricks we can do. Wonder how far we're getting actually. That's something we could investigate by simply putting out like an alert. So we could do like, let's see how far we get. Alert 1, or no, let's use console log. I'm here, 1. This will be adorable. 2, 3. Wonder how many of these we'll get. That. All right. Now we are printf debugging the JavaScript engine inside the JavaScript. That's pretty cool. And I don't see any console logs. Not a single one. That's a bit concerning. Oh, because maybe they showed up on the terminal. I wish they would show up in both places. Yeah, they're here. I'm here 4. All right. This is the most advanced printf debugging I've ever done in my life, I think. 4. We're here, 4. So after 4, something goes wrong. So I'm guessing that maybe one of these guys is invalid. We can do some cool stuff like this. 4A, 4B, 4C. See, this is going to be very, very helpful. All right, that's enough. Okay, render that business, and we are here 4A, and then we didn't make it any farther. All right, that's good. That means that we got all the way to this part right here, and I'm guessing that the scene object isn't quite what we thought it would be. So how about we log it? Scene. It would be cool if you could have if you could break to a REPL exactly where the problem is, but like that'll take a lot of work that is not the type of work I want to do right now. So it's an array. Okay, so it is an array. And maybe dot length. Maybe the problem is that it's empty. Let's see, length is 3. Okay. Oh wait, scene is an array, but scene lights. What is that? Scene lights. And then we'll log scene lights length. Maybe scene lights is not a thing. Scene lights is undefined. Well, well, well. Where is scene? Scene, cine. Okay, so it's this thing right here. And we were calling new scene. We're not passing the second argument. That seems like it should be okay. Why is this lights thing not present? That doesn't seem right. So, new scene. Wait, why is scene an array? Why is scene an array? That's so weird. Is it that this function... Wait a minute. The very last expression evaluated in this function is an array. I wonder if it's because of that. What if we do like return those? Okay, now we made it way farther, and then we got other problems. Okay, so that's good. That means that we're just taking the last expression in the function and giving you that, which we shouldn't do because there was no return statement here. All right, so I guess maybe we have some patches to assemble actually. Yeah, let's add the number object stuff. So add this guy, that guy, and this guy. Get diff. Wait, the number object needs to have some stuff. Needs this little interpreter change, but not all the other interpreter changes. And then we need interpreter.h as well, and make file, and value. Okay, so we'll start with value and make file, and then get add I. Wait, there's some other get add. Is it P, the one that goes right into the patch? Yes, that one is awesome. So, oh, I don't want this to die. Oh. So let's just take that one out temporarily. All right, yes. 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 No. And for H, no. Yes. Yes. Man, get add dash P is awesome. Okay, so let's commit this. With JS add number object, make two object on number values, make create it. All right. And then we can put that thing back. And then we had the Lexer change just to hack it so that we can have numbers with decimals. It's very hackish. But we'll live with it for now. Hack the Lexer to allow number fractions, or what do you call these? Numbers with decimals. Is very hackish and should definitely be improved. Okay. Right, and then we're sort of back where we want to be. Right, these are just my debugging tricks, yes. So, what was the problem then? I have to... Let's just refresh ourselves a little bit here to make sure everything is up to date. I shouldn't have done a sync so early. Okay, so... Oh, right, yeah, we had that problem. I already forgot what the problem was. So it's the new expression, which is a call expression, and it uses the last value evaluated in the constructor as the thing. So let's see, the result of the is new expression. Result is call construct. And then if it's a new expression, then if a result is an object, then we use that. So I think calling construct, what does that do? So we're just calling a function. It's a script function. We do a call, and we do interpreter run. And what do we return from here? Last value. But I feel like we shouldn't return the last value unless unless there was an actual return that happened. But how do we know that? So this one is a bit tricksy. I'm not exactly sure what the best solution here is. Just, So we run a statement, because like normally when you're in the REPL, then if you run a statement, you know, like 1 plus 2, then you want to show the result of the statement. But if you're executing a function that just ends on a statement, so if you got like function foo, 1 plus 2, foo, then it doesn't return 3. Because the result of the function, the call expression is not the last value generated inside the function. So let's see. I guess if we're here, then this is like the REPL path, and then this here is running a block. So if we run a block, maybe we should never return the last value unless we did a return. So let's see what we do when we get a return. Return statement. So when we execute a return statement, we do an unwind to the function scope that we're in. So we exit the current function scope. And if we look here, the way that unwind works is that after you execute every node, we look if we're supposed to unwind to anything, and if so, we break out of this guy right here. And then if we've unwound until the current type of scope that we're in, then we stop unwinding at that point. So I'm thinking that if m unwind until is if it's not return, then we can drop the value. We can say did return is m unwind until is scope type function. Did return, yeah, and then if we did a return, otherwise we will return JS undefined, I guess. So this is not perfect, but it is something. I feel like this will at least solve the problem that we're having right now. And oh, and we should actually make sure that we have all that debug logging that I added now, but maybe that's okay. Undefined is not a function. Now we're here 8. Alright, so I think that's going to be this guy right here, index of. because that's not implemented. User agent is a string, so we can get that. So if we just disable this, see how far we get. I'm just kind of curious. It's going to fast track a little bit right now. Poof. Look at that. We made red. That's pretty cool. And then we threw something, type error. This is our call stack, so we're calling render, which calls camera render, with scene and canvas and so on. So we are in, yeah, we're in camera render. That's awesome that we're actually making some color happen. I feel like we're not parsing these properties right, so I'm just gonna hack them manually for a second. And maybe we'll also put this link up top. Put everything up top. And maybe we'll get rid of all the gunk inside of the canvas. So we're hacking the test a little bit at this point, just to make it a little easier to work with. Click. All right, this is the rendered scene. Well, one step at a time, you know? So let's just go and look at his thing to see what the result is supposed to be. So we want to get to this point. Now, this is not this yet. So I guess we can implement index of string prototype value index of string prototype index of, oh, what's my phone saying? I'm just gonna get something more to drink. All right, we're back. Got some more tea. Man, we are putting in some serious time today. So let's see about index of. It should return the index within the string of the first occurrence of the specified value, starting from index, which is optional. And oh, this feels extremely JavaScripty. If you don't provide a string, it will be coerced into undefined, and it will be searched for. Right. Adorable. Okay, so string prototype, we'll just add put native function. Wait, did I do those things correctly in the math object? I should have added, oh shit, I didn't do this correctly, because this takes one parameter, so just realized that I forgot about that. Let's fix that right away. JS math, squirt length should be 1, I think, right? That's how that works. Math squirt length, yeah. Because that's how many arguments it takes. So Linus added this, so very nice. Now we actually set the correct length on native functions. Maybe we should make this argument mandatory. I guess now it's default to 0. That's why, yeah, maybe it should be mandatory, so you still have to say 0, but whatever. Index of, so string prototype index of length is 1. Okay. So I think this code is a little bit messy. Index of. if, let's see, so value needle is JS undefined. And then if interpreter argument count is greater than 1 or equal to 1, then needle is interpreter argument 0. Cool. And then we want to turn that into a string. So needle string is needle to string. And then we want to search for that inside of this object. So let's see, we can copy it this way. Yeah, we'll do this. So if you're calling this on something that's not a string, then we'll just whine about it and die. And then this is how we get the string out here. Okay, and then haystack string dot. Do we have something like index of find? No, I guess we can do stir. Do we have stir anywhere in ACK? We're using it here. Contains, but we don't have index of. Well, maybe we'll survive with just stir right now. Man, stir. Because I kind of don't want to edit the ACK headers because I don't want to rebuild everything. Wait, what's that? Index. Locate a character in a string. Well, that's not quite what I want. Okay, so location, or let's just call this, I don't know, putter. Stir. No, not you. Tell me about yourself. Haystack and then needle. Okay. So haystack, characters, needle, string characters. I think we'll change these around a little bit and call this just needle. I love these names, by the way, needle and haystack, for like looking for something inside something else. It's so expressive. Stir, fix me. This should. We should have a helper in ACK string for this. So if putter is null, then what should we say? Return value -1, right? Okay, otherwise return the offset from putter to the start of the haystack. So return value putter minus haystack characters. And I guess we'll just use flat putters here. I think it might be the easiest. Ambiguous conversion. Okay, let's do it this other way then. So we'll minus these guys, and then we'll say flat footer that way. I32, fine, that's okay too. Okay, so let's try this. JS foo index of f undefined. See, that's not what I was hoping for. Did it throw? Undefined. I guess you would get here if you don't have this object. Wait, what? String foo. Oh, we don't have a string constructor. Okay. Foo dot. Oops. Parse problems. Of. Did I not set that up? I did. Index of that length undefined. Okay, am I just not rebuilding everything correctly? Char at 0. Oh, this is not working. Why is this not working? What? Var foo is foo dot char at. Oh shit, I broke that. That's the return thing. I just don't see what I'm doing with the REPL. Okay, so I'm evaluating some expression. Dang it. Okay, we didn't commit that yet, did we? No, I don't think so. Wait, where was that change? It was in the interpreter. If we do return, then it's the last value. Otherwise, it's undefined. So this was in interpreter run. So this was not good enough, I guess, for the REPL. Because I thought we would always be here in the REPL. We would be running individual non-scope statements, but I guess maybe what we're actually giving to the interpreter is a full program every time. Because if we look at what the REPL is actually executing, so we do like it actually parses an entire program, which will contain a block body. So it does not take this path here in the REPL. Okay. That's a little bit annoying though, because we kind of want to parse anything in the REPL. Maybe the interpreter could just store a member variable with the last node execution thing, last value. So we could do like m last value node execute this, and what if we do that? It's a little bit weird, and then this would instead be like the return value. Okay, and then interpreter will have m last value, so value, m last value. And we'll have a way to access it, last value, const return m last value. And we got to make sure that the garbage collector doesn't take this from us. So do like if m last value is a cell, then m last value needs to be in the roots. All right. So, and then in the JS REPL, what we want to print here is, wait, this just calls run directly. Oh, that's so weird. But we still only want to, okay. Let's try this anyway. Interpreter last value. This is a bit strange, but maybe this will work for us. Maybe there's a better way to do this. I just can't think of it right now. But we need our REPL to work, otherwise this becomes very unbearable. That's not what I was expecting. 1 + 2, no. Okay, that's not good. Oh wait, I'm running the nodes twice. That's not very good. Should take the return value. Did return. Actually, why don't we do it this way instead? M last value is JN empty, and then that, and then here we'll just say like that. And probably in the REPL I didn't update the right place, now that I think about it. Print, there's more than one place. Yeah, this is the REPL loop. This is not the REPL loop. So let me put this back the way it was. Maybe we can even undo all the way back, yeah. And then here we need to last value. Okay, I think this will work better. Yes, okay, so foo index of, damn it. Foo index of O is 1. That's true. Hello friends, dot index of fre. That's very nice. And what if it's not found? Hello, index of friends, -1. Shit's working. All right. So let's add the string prototype stuff, and we'll make a quick test. So libjs tests string prototype char at can be string prototype index of. And we don't do the second argument right now. That's a fix me for the future. So here we'll do hello friends. And we'll assert that index of friends is 6. And that there are no enemies whatsoever. That's a pass. Let's verify it inside. And actually, let's run all the other tests as well, for that matter. This is the wrong place. See that everything still works. Oh, I think because we're printfing when this happens, then they will break. But the string prototype index of seems to work. That's great. So commit that, commit libjs add string prototype index of, and let's do that REPL change thing, or rather the way that return values are handled. Which code do we need to add? We need interpreter, CPP, and the H file. No, yes, no, yes, yes, no. Okay. Don't return the last computed value from interpreter 1. Only return whatever a return statement told us to return. This, yes, the last computed value is now available in interpreter last value instead, where the REPL can pick it up. Okay, cool, and then this is just the debug stuff. Okay, great. So let's see where we're at now with the test with the Raytracer thingy. Okay, so browser, clickety-click, it's all red, and we have a type error. That's fine. So, oh, but we forgot to re-enable that index of check. So let's just put that back, be a bit more genuine. Because it's just looking if the user agent string contains iPhone, which it shouldn't. We don't pretend to be an iPhone. So that is fantastic. We can actually get rid of a bunch of this I'm here stuff. So we'll just get rid of all these logs. And here, I guess we can say calling camera.render. I just want to see that we're in a healthy place with the test being not super tampered with. Okay, so let's look for that type error that we're throwing. So we're inside the camera render thing. That's great. So what's going on in there? Renderer. So probably we are, undefined is not a function, so we're calling something that does not exist. So it's probably either this guy or this guy, because we don't have those canvas functions. And we don't have get image data either. That's going to be a little bit of a problem. Get image data. What is he trying to do with that? Create image data. You're just adding a function to add get image data, but I don't have that. Okay, it's a little bit of polyfilling going on here, I guess, but it's very ancient stuff. Okay, so we'll need scale and translate on the canvas. That's at least where we have to start. So let's see, canvas rendering context 2D, scale, let's say double x double y, I guess, or scale x scale y. And then we also had translate. And double y. All right, and then we need to store this somewhere, so I guess we can just store it here, like scale x. And maybe we should store this as a, I don't know what to store this as. X translation. I don't like these names so much, but whatever. We're just gonna like load them in. So we'll see void canvas rendering context scale. I think for now we're just gonna log the fact that this is happening. We don't have support for scaling anywhere in the graphics stack. So this will be a little bit of work to get this working, but gotta start somewhere. We can't pass that. Can we pass it as a float? No. All right. What if we do a string format %f, deal with it, .gif. All right. Close enough. And let's do the same for translate. Translate. I just want to log that these are happening, and then in the wrapper for this code, we have to add these guys. So native function scale, 2 arguments, and translate, 2 arguments as well. Okay, and then we will implement them. We'll just copy paste fill rect. Let's say scale. If we have 2 or more arguments, then we just pass the 2 number as double. Arguments 2 number as double. Can this fail? I feel like it shouldn't fail. I think. Maybe it would. I'm unsure if 2 number can fail. Maybe it can. I'm not sure. Right now we're pretending that it can't. So that's fine. And let's implement translate in the exact same way. Crab skate. Crabs skating on an open fire. Getting a little bit tired. That's not where I wanted to go. I wanted to go here. All right, so look at that. We're calling more stuff. Continue, not known. Oh, it thinks continue is an identifier. Interesting. So we didn't parse that. But look at this. We are scaling and translating the fine canvas context. That's pretty cool. So I guess here we'll just say m translate x is x, m translate y is y. Fix me. Actually do something with the scale factor. And then we'll say the same here. With web, add canvas context or canvas rendering context to the scale and translate stubs. Don't do anything for now. Okay, then our problem was continue. Right, continue as, I guess it's supposed to be parsed into some kind of statement, right? So continue can't be here. All right, so what if for I 0, I 3 plus I, then you can have continue. Okay. Continue. It's a continue statement. And it has an optional label, but we don't have that. But we have a break statement, which works differently from continue, obviously, but we can start from there, because break statements are supposed to have labels as well, but it's not supported here yet. Labels are kind of neat, though. So let's just say for continue, I guess it's like we don't want to unwind technically, but we can use the unwind mechanism to do a continue instead. Well, it's a little bit strange, but I think maybe it'll work. This needs to have more correctness enforcement also. Continuable, let's say. Breakable. Oh, wait, this is weird. We unwind. We want to do a continue then. Okay, do continue. Do continue. So this will be some special mode where we say like unwind until scope type breakable. Wait, is that what we're supposed to do? I guess so. We have to unwind until we're breakable. To the next breakable scope and then continue there. So should continue is true. Okay, and then I'm just thinking how we're going to set this up. I'm kind of hoping that we're not going to need this M should continue. So how the heck does this work now? So we're from a for statement, for example. So we're in for statement execute. Then we are doing this here. If test, while I'm test execute. So in a for loop, I'm doing this. I'm not sure it's possible to break out of a for loop right now. Last value. If you have an exception, yeah, this doesn't take any breaking into account. Okay, maybe we can do a small fix for this. Let's see what's the actual use case. Oh, it's a bunch of them. Great. Continue. So this is continue in a for loop, for loop, for loop, for loop. All for loops. All right. And in this guy, let's continue inside of what? Inside of a do. Okay, inside of a for loop, and inside of a comment. The rare comment loop. Okay. And a for loop again. So for and do while. All right, so we have to actually deal with continue here. So continue will unwind to the breakable point, and then we'll come out here Wait, what's even breakable? Breakable. What do we currently consider breakable? Wait a minute. Did I not use this for anything? No, it's the break statement, but nobody sets the scope type. Wait a minute. Why does this work? Does this work? I am so confused. So, do we have break somewhere? Yes, in the switch test. Oh, I guess this guy will just unwind all the way out. So switch, this guy needs to be a breakable scope. Because otherwise, like, if you're in a while, then let's see, so I0. Wait, let's make a new test. Switch, break. So I0. And let's get rid of all these. And let's just say switch I while I is less than 9. Case 3 console.log3 break plus I. So we should print 3 and also cool 5, and then we should eventually finish 3, 5 pass, right? So I think this is gonna go really badly with our interpreter because we don't actually say that the switch scope is breakable. Switch break. Unexpected token while. Oh shit, right, because we don't even parse those. Let's not get into that, but let's instead do something different. So switch break.js. Okay, 4 unrelated. All right, maybe this will still work. This still works here, right? Yes. Switch break. Not working super well. Okay, so that didn't even fail in the way I was expecting it, but at least it failed. So we just print 3 over and over. Because break will unwind and bring us back somewhere. I don't know where. Anyway, in the switch statement, when we execute it, we should be able to let's see. So we have to look at the unwind status here, I think. This is the test. And then this is the statement. So, oh, this is how we unwind. If we should unwind for any reason, then we unwind. Okay, and then I guess here we should check if we need to look at the unwind until state. Should unwind until scope type type. Okay. So we can say if we should unwind until scope type breakable, interpreter. So we'll stop the unwind at this point. So this is maybe a little bit unexpressive, so we can do a little bit better. Stop unwind. Unwind until is scope type none. So yeah, stop unwind. So, but now we're just fixing the switch statement, but at least that's still good to fix, even though it doesn't give us any progress on the other stuff. At least it helps us understand how to make break and continue work correctly. So let's see. Switch break. Nope, still not doing the right thing. All right. Should unwind. We'll return at that point. Oh, wait, hold on. We shouldn't return. We should just break. Actually, let's see. If we should unwind until breakable, so we can do it this way. Yeah, like this. We'll stop the unwind ourselves instead of letting the outer, our caller, our calling AST node unwind. We just do the unwind ourselves. Wait, that's not what I wanted to do. 3.5 pass. Cool. So let's see, let's make that into an actually runnable test. So let's just grab this little assertion helper and say try. And then we'll add two variables here, 3, 5. 3 is I, 5 is I, and then, wait, what are we doing? I can't see the whole code. It's confusing. Switch, this guy, that guy. All right, so catch something, whatever. Catching is not so important. We just got to print pass. Assert. 3 is 3. 5 is 5. Okay, that works. Let's test it in our engine. Switch break. It's a pass. All right. So let's add test. And I forgot which changes. This is getting a little bit confusing with all this stuff. So we need the interpreter. Oh, we didn't need should continue yet. So let's not add that yet. I'm still suspicious about that one. Okay, so git add p libjs interpreter cpp. No. 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 Yes. No. Eh. Meh. Yes. No. And this was just the continue statement, right? So we'll say JS make break actually work inside switch. Okay. And then I think we can start by we can just add the parsing part for the continue statement. So in the parser, this will just be very simple, like this continue statement. Okay. This looks a bit weird here, so we're just going to put this in a normal way. And here we need to also catch continue statements. Oopsie doopsie. Continue. So let's make a little test for this actually. Continue basic. So let's do this one is actually kind of nice because we can just do, what do we want to do? We want to continue. In the case of 3, console.log 3. Wait, what do we want to do? Saw 3. But then we're skipping over this guy. So how do we test the continue? Wow, my brain is getting a little bit mushy. How do we test continue? I guess we can simplify this. Let's do this like this instead. If I is 3, continue, otherwise plus j, and then we will assert that j is 8, not 9. How about that? It's very good. All right, and then let's see, we can make this right. Let's see that we can parse it right. So JS test, JS, continue basic, continue not now. Oh shit, wait, I guess we are not doing this correctly, or are we? Wait. Token type continue. Oh, but we're still not, probably still not doing this part correctly. We have to actually add it here to the Lexer. Continue basic. Well, that didn't work. Didn't do anything, actually. What was I expecting it to do? Expecting it to say pass. But it didn't say pass, so we failed. Continue did nothing. Alright, so for statement, when we execute this guy, he needs to look for a continue statement. Wait, scope type. I guess it's not so much breakable. Yeah, it is breakable and continuable. Yeah, let's say that. And these are just, because when you unwind, you ask to unwind it to a certain scope type, right? So let's just say that you can unwind to the continual scope. And then we'll just have to deal with that in the loop code. So in the interpreter, should continue, unwind to continuable scope. Maybe this is enough. We'll see. For statement, execute. So after we have done some kind of, we run the body, and then if should unwind until scope type continuable, then we'll swallow the unwind here. Stop unwind, and then keep going. But if we get an unwind that's not continuable, then let's see. So if it's too breakable, then we will break out of this loop that we're in here. Otherwise, we will return if this is a different type, but we should swallow that one as well. Okay. That makes sense to me. And we'll do the same thing down here if we don't have a test. Okay. That was troublesome. How did I mess this up now? Forgot it. Close curly. Then we don't need should continue, so the interpreter can actually be simplified. This guy can just do unwind. Well, we'll see if the test even works. Continue basic. No, it doesn't work. Unwind until all right. And then let's get rid of do continue, should continue. So we are in for statement execute at the moment. So we're here and we're running this code and we got to continue. So we have a test in our for loop. So we are in this path here. We're running the body. We don't get an exception, but we are supposed to unwind. And we're supposed to unwind until the continuable scope. So we stop the unwind. Oh, and we should else here, because we've already handled the situation. The wrapper here. Oh, wait a minute. If we return early, then we don't exit from the wrapper. We should fix that too, but that's another issue. I think the scope stack is incorrect if you throw an exception inside of a for loop, but we can fix that. So let's do the same thing down here. Else. Return. Yeah. All right. So starting with that. Okay, what is our problem now? Undefined is not a function. Okay. So we have an array expression with a call inside of it. And we are in a call to canvas.setFillColor. Let's look for that. Set fill color. Render.js set fill color. Oh, look at that. It's calling floor. And it's math.floor. Okay, wait. I forgot to actually test our continue test. Okay, I am starting to get a little bit hazy, a little too hazy almost, but we can go a little bit more. This passes. That's awesome. So let's add our continue statement, even though it's still very naive, but still cool. So this guy, yes, CPP, not you. Yes, you. Yes, you. Okay, we'll just bring that one along, whatever. And I think we have, not here, right, but in the header. Yes. Oh. The JS. Add support for continue inside for statements. Okay. And just so I don't forget this, when we create this anonymous wrapper block, then we got to make sure that we clean it up on exit. So we'll make a scope guard, which is this nice thing we have in ACK. So you can just make a scope guard and it will always run something on when destroyed. So scope guard. Then whatever we were going to do on exit here, exit the scope. Clickety. Yes. We can actually even only make it if, or no, like, that doesn't matter. That's good the way it is. Let's just verify that everything still runs. I think we'll still have some debug output from exceptions that will make exception tests red, but outside of that, we should be good. Yeah, it still does. Very cool. So this guy, yes, no, yes, yes, no. Clean up the anonymous wrapper block in 4 using scope guard. This ensures that we don't forget to pop the wrapper off of the scope stack if we were when returning early due to exception or some such. Okay, that's pretty cool. Then where the heck were we? Set fill color. Right. Oh, the floor. Math object floor. We can add that. Floor. Really simple. And I think that just did it. Oops. Math floor 0, 5, 0. Math floor 10 dot. Look at that. Very nice. I clicked and it ran for quite a while. And dare I say it, I think the top line is black, not red. But I may be wrong about that actually. Type error. So where are you now? Our call stack is we are in camera render, obviously. Now we're getting another undefined is not a function, so wait, do we have stuff to commit? Yes, we do. Okay, I'm gonna be a little bit lazy now and not add a test for this one. JS add math floor, because now I'm starting to get a little tired and I just want to move forward a little bit faster. So let's find out what that thing was. Render. So we're in here and we're calling something that we don't know what it is. So probably, is it math round, maybe? Math object, we didn't have round. Okay, we can add that. These are easy. So round. I think we already have this in libm. Well, we have round f. All right, well, we'll just call round f on this one. Sorry. We'll say use round instead of round f. Just need to add round to libm. Click. All right, now what went wrong? Undefined is not a function. We're still in camera render. All right. Maybe there was something more. I did set that up, right? Yeah. JS add math round. Let's actually verify that it works. Maybe I didn't even rebuild actually. Did that build the browser? Linking browser, yes. Okay. Math.round 0.4. Math.round 0.6. Okay, it works. Cool. Okay, what are we trying to call now? Again, in camera render. Camera render. What else are we calling here? So we have floor. We have math max. Oh, we don't have math max. Seems like we can add that too. Math max. Why don't we? these are pretty boilerplatey, but what are you going to do? So I guess math prototype max takes 2 arguments, right? Or it's not math prototype, it's math. It's math, just math max. Wait, have I been saying math.prototype? No. The largest of 0 or more numbers. Wait, what? Largest of 0 or more numbers. Okay, more JavaScript goofiness. So that's negative infinity. Okay. Should say fix me. I think this should return negative infinity. And I think we'll only deal, or let's see what kind of use case we have going on here. Max is using 2 arguments. Yeah, so we'll only deal with 2 arguments. I think that's okay. If interpreter argument count is 2, and return value A as double greater than B as double A B. Fix me, support math max with more than 2. I guess we can do that. Wait, what happens if you run math max foo? Comes nan to number. I'm just guessing at this point. So what is math max length then? It's 2. Okay, all right. Well, we're adding it. Put a 2 there. Math max 3, 5. Math max, that doesn't seem right. 5, 3. Okay, why is it like that? If the argument counts negative. B, so if A is greater than B, then return A. Oh, because we were using argument 0 in both cases. Math max 1, 2. Math max 2, 1. Great. Render yourself. Okay. Oh, set timeout. Interesting. What is one a set timeout? Set timeout. I guess we can quickly implement that in window object because we have set interval, so we can do set timeout. Also, I feel like set interval should have 2 arguments, no? No, just a 1? Okay, shows what I know. Maybe I don't understand how this thing works. Set timeout. Alright, set interval. So set interval and set timeout are the same, except set timeout, it's a single shot. So it only gets called once, whereas set timeout gets called. Well, set timeout gets called once, set interval gets called repeatedly. But you already know this if you are web savvy, or even not so savvy. It's like I think this was one of the first things that I remember learning about JavaScript when I started trying to make funny things with it. So we need something on the window object. And yeah, so this is very hackish already. We'll just do something very hackish here too. So we'll make a timer and we'll set it to single shot, which means that it won't reload. Set single shot true. Yeah, so it'll be just the same as set interval, just we'll still leak it, but it won't get called repeatedly. Cam not known. Okay. Grab cam. Cam is this. Alright. Var cam is this. Where's cam used? Cam. Nobody else is using cam. Oh, wait, I see it. It's in set timeout. Oh. We don't see cam there. This, it needs to see cam inside of here. It needs to be captured somehow. Oh, hey. Okay, I'm starting to get too tired for this kind of stuff. So we're gonna do a little bit of workaround right now. And we'll just say cam is this here. Still failing? Seen, not known. Oh, it's more stuff like that. Okay, so we'll have to make globals out of these. Seen. Or no, that's too much. Hello friends, seen. Hello friends, cam. Hello friends, canvas. Hello friends, width and height. And noon lines. Yeah. Okay, so total hack starting now. Canvas, width is width, height is height, and new lines is new lines. Because I don't have the energy to start working on capturing these things. Okay, so what are we failing at now? Cam not known. Oh, wait. I forgot to actually change what it says. So HF. Still failing. Cannot, no, wait. How am I messing this up? Oh, there. All right, my bad. Now what? Gray is not known. What's gray? Red gray. Raytracer. Gray. Oh, there's another capture situation right here. It doesn't see it. So green also not used there. So I'll just move them inside. It's very lazy, but it's my progress. It is actually running, doing something. I have no idea what. I feel like we're not going to see it for a while. This percentage here is a little too detailed. Stacks. It's very aggressively running JavaScript. Okay. I wonder if we can make this run in a way smaller viewport, maybe. Because I just used that. That would be really nice if we could just... Yeah, I think we can. Let's try that. How about we do 80 by 80? Render. Yes, maybe we can actually do this. Because, like, this thing takes, what did it take? 1.5 seconds on a frickin' like modern optimizing JIT compiler on my machine. So on the Serenity unoptimized JavaScript engine, it's probably going to take forever, even if it's correct, which I suspect it's not, but we can at least see it do something maybe. Oh, and we got a failure. Camera not known. Grab camera. Camera, render, camera. Oh, there's another set timeout here. Or let's say XX camera. Which things did we need down there? All of these things. All right. So camera, scene, canvas, width, height, stop, Y, and num lines. Okay, and then we'll do that, and then we'll say not var, but Oops. Okay. See if this still runs here. Okay, it runs here. Still, like, it's still a little bit too long, actually. So, Ray.js. Let's take it down to 40 by 40. Because how long does that take here? Yeah. It's still working real hard, as you can see. And start date is not known. Well, I guess it actually finished. Just sure it doesn't look right, but start date is the get time. Start date. Oh, it's another capture. More captures. Date. We'll just do this. Actually, we'll just put it on the global object. And maybe that's enough. Maybe we can actually run the whole thing, even if it doesn't come out right. That would still be something. Okay, all right. What do we have now? Type error. We're in render rows. And the call to time taken. Time taken. Unfinished. Okay, that's kind of nice. So we're in unfinished and we're trying to call log. Oh, and now it's trying to do the DOM manipulation. Okay, I'm not going to deal with that right now. So we're just going to say console dot inner HTML is stir. Yeah, we'll do that. Oh, okay, come on now. We're almost there. We're almost there. It's not going to come out right, but it's going to come out. Look at that. We ran to completion. That's exactly what Oliver would say, and I think that's as far as we're going to get today. So I've been doing this for a while now, so I have to, I gotta wrap it up. But we made the test run to completion. Now we'll leave the actually rendering correctly for another day. But I'm really glad that we were able to get this far. I feel like we got a lot of stuff done, so it's really good stuff. And thank you for watching. And if you're still here, wow, dude, I really appreciate you sticking it out with me. And I hope you saw some interesting stuff. And this project is really fun so far. I really like the browser and JavaScript engine and the operating system and everything. And I hope that you find it interesting as well. So thanks again for hanging out. And I gotta go sleep. So I'll see you next time. Bye.